Hello and welcome to the Superposition Guys podcast. My name is Yuval, and my guests today are Professor Peter Coggy from Notre Dame, Professor Geraldo Ortiz from Indiana University, and Dr. David Stewart, Managing Director of the Purdue Quantum Science and Engineering Institute. We talk about the new Center for Quantum Technologies, a multi-site NSF-funded research center. Which commercial sponsors are participating in the center and what they expect to get from it, the diverse faculty and students that participate in quantum research, and much more. We hope you enjoyed this episode. Hello, David. Hello, Peter. Hello, Gerardo. Thank you so much for joining me today.
Thank you.
Thanks for having us.
So, who are you and what do you do?
So my name is Gerardo Ortiz, and I am professor of physics at Indiana University, and I'm also scientific director of the Quantum Science and Engineering Center and site director of the Center for Quantum Technologies.
I can go. I'm David Stewart. I'm the managing director of the Purdue Quantum Science and Engineering Institute, and I am also serving as the industry liaison officer for this new Center for Quantum Technologies.
And I'm Peter Kogi. I'm a retired IBM fellow, and I've been at Notre Dame for over 25 years as the McCourtney Professor of Computer Science, and I'm director of the Notre Dame site of the CQT.
Excellent. So this sounds like a multi-university Center for Quantum Technologies. I think Purdue, Notre Dame, Indiana. David, how did this come about? How did the center start, and how long did it take to set it up?
Yep. It is, as you mentioned, a three-university partnership between Purdue and Notre Dame and Indiana, which Indiana involves both the Bloomington and Indianapolis campuses. This started almost 3 years ago. We sort of got this idea in our head, saw this opportunity through NSF, and really began working on it. And we, already had good ties across the three universities being so close to each other in the state of Indiana, and started working on it from there. So it's been a somewhat laborious process, but we've made it all the way to the end. We just got the official word from NSF about a month ago that the full phase one center has been funded, which will be for 5 years.
Fantastic. And Peter, and then maybe Gerardo, what is the division of labor between the various universities? Do you all do the same thing, or is one university focused more, say, on communications, where the other more on computing? How does that work?
In terms of research areas, we all pretty well overlap. In each site, it's not just the director, but there's a whole cadre of people from multiple departments who are interested in quantum, and a lot of them are drawing on pre-existing collaborations across universities. So this isn't hi, my name is. It's more of a we've worked together before, and there's now the opportunity to look at some really new and neat problems.
So absolutely, I mean there are quantum strength in all universities, and the whole idea is to coordinate those efforts to essentially the whole being more than the sum of its constituent parts. That's the whole idea. Of course, there are a certain strength in certain universities, in certain areas, more on quantum communication or more on quantum sensing or more on quantum computing. But in the end, the whole idea is to coordinate these efforts to make, a huge or large impact at the national and international level.
How many students and faculty in total are approximately involved in this center?
So, in principle, there are more than 100 faculty members if you count through the whole universities. And you can think that, on average, there are like 3 students per faculty at least working in the area. So that gives you an idea. Plus, the postdocs give you an idea of the size of this enterprise. I mean, it's certainly a very large set of uh, 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 people and talent involved in this enterprise.
One of the problems that's often mentioned in the quantum industry is the lack of qualified people. And obviously, a center like yours can educate and produce many people that could then flow into industry. Do you have a degree in quantum, quantum information science degree, or something that people could say, "Oh, I've got a quantum degree, and therefore I'm even more super qualified to work"? And if not, is there a plan to create a quantum centric degree?
So I can answer. I mean, yes, certainly this is a very important question because we have to develop the quantum workforce of the future. Okay, this is an extremely interdisciplinary thing. And indeed, we do have at Indiana University of Bloomington a degree already that started a couple of years ago, precisely with intention of focusing on that workforce. Okay. So far has been very successful, and we are getting more students every year. But this is not something that we are only doing. I mean, Purdue and Notre Dame, they are trying to establish their own programs, and probably David and Peter can expand on those things.
Sure. I literally just last week had a meeting with our Dean of Engineering about what might be involved with setting up at least a minor in quantum or a specialization in quantum for at least our undergraduates.
Yeah, and I think Indiana is leading the way here as far as having an actual quantum degree. Purdue's not quite there yet. Most of our quantum students either get ECE or physics degrees, as well as a number of other disciplines as well. But Purdue does offer a quantum micromasters course that's all done online. It's just sort of a little, it's about a year long, 10-month or so long snippet to kind of get your feet wet.
Interesting. And I think Madison has some kind of a certificate or a 1-year program in quantum where on one hand you get the certificate, and I guess the challenge is that there's so many different disciplines in quantum that it's hard to become an expert in everything. David, I wanted to ask you, I think beyond NSF funding, there are industry partners in the center. What do you think they are hoping to get from sponsoring the Quantum Center?
Yeah, absolutely. There's significant value proposition, and maybe I should give a little background on kind of the framework of the center, as maybe not a lot of your listeners are familiar with IUCRCs, but that acronym stands for Industry University Cooperative Research Center. This is an NSF program that's been funded for about 3 decades now. And there are about 80 of these IUCRCs throughout the country. And the way they function is NSF provides funding for all the management and administrative costs. They don't actually give any dollars for research. The research funding all comes from the members that pay in annual dues. And the centers are very unique in that the members actually select the projects that are done on the center. So our faculty across the 3 universities will come together. They will pitch projects to our membership, which form a board, and then they collectively vote on the projects together to decide which ones get funded. So it's very unique in that the members have really a strong say in the research direction of the center. Back to your original question, there's significant value for the membership. One of the biggest ones we hear, and we've already talked about workforce, is you get access to talent, right? So one stat that NSF always likes to say is that 25% of IUCRC students eventually become employed by member companies. So, right, you get a firsthand look at the wonderful talent that we have in place. it can sort of even serve as an interview before you bring someone in for an interview. So the access to talent is one. There's risk mitigation because you're sharing those risks with like-minded peers in the field. Research costs are lower than hiring your own, quantum engineer to come because grad students, of course, are a little cheaper to fund than hiring a full-time employee. And, the universities also already have world-class infrastructure in place to do this type of research. You're pooling your research dollars with other members, and there's significant leverage there. So at the moment, we currently have 1.1 million per year committed across NSF and our membership. So right now, our full membership fee is $50,000 annually. So that's a 22-to-1 leverage right now that you get on your return. So other things are you get network opportunities with of course the faculty and students in the center, but also the other members that are involved, and then everyone gets royalty-free, non-exclusive license to any IP that's produced in the center.
Could you disclose some of the members, some of the industrial supporters of the center, and to the extent this has already been decided, maybe some of the projects that you guys are working on?
Yeah, I'm happy to tell you all of our members, and I don't want to leave anybody out, so I'll just say them all here. We have Accenture, Air Force Research Lab, BASF, Cummins, D-Wave, Eli Lilly, Entanglement, General Atomics, Hewlett-Packard, IBM Quantum, Intel, the Naval Surface Warfare Center at Crane, Northrop Grumman, Quantum Computing Inc., Crypt, and Skywater. So that's our current membership, 16 total at the moment. We are expecting a few more to be added here, hopefully in the next coming weeks and months. What was the second part to your question? I'm sorry.
Whether you can talk about projects that have already been started or voted on.
Yeah, I'll maybe let Gerardo or Peter talk a little more about the projects. But as I mentioned, we haven't actually had our first meeting with our membership, so we don't, know for sure which projects are officially going to be funded. But I'll let them give a little bit more insight into what our potential topic areas are.
Sure, and I'll give it a start. We had when we started this effort, we came up with a book of potential projects where we interrogated our local faculty about what would be of interest, and we bounced those off of people as we talked to them off of industrial contacts to find out which of those excited them the most. And then after that, we went back and refined that and looked for collaborations where they were naturally formed between sites in the CQT, and refined those, came up with a list, I think, of about 16 projects that looked like we were trying to answer their interests and that matched our qualifications. Bounced those off in some early meetings with the industrial partners, and got a sense of what they thought would be the most important ones. And those projects will be the ones that we refine and present for the vote the next time.
Yeah, I mean, these projects cover in principle a wide spectrum. They cover things that goes from quantum computing, quantum simulations, to quantum hardware, to quantum sensing. Okay, that's extremely important. Quantum materials. Okay, so we can tell you what are the projects that were presented, but the thing is that the reality is that there will be a vote, the final vote in that meeting. So that is what is going to be decided. The other thing that is important to mention is that this is not a fixed set of proposals. These proposals may evolve through the years. Okay, so it may happen that someone starts working, let's say, on quantum benchmarking, okay, on certain on available quantum computers, okay. And it turns out that, this starts going in some direction that is extremely interesting. And, that gets expanded. But there will be another project on quantum sensing that essentially that it does not get, voted next year. And then you will have to start adapting, the set of projects that the center is going to work on. Okay, so the point is that this is not just a fixed set of proposals, but it's something that will evolve according to the interest of the industrial partners.
Yeah, and I'd like to add to Gerardo's point there. He mentioned earlier we have over 100 faculty across the three universities, right? So it gives us extreme flexibility to be able to evolve and change to meet the needs of our membership as their needs evolve.
I'm curious,
And
Gerardo, and then maybe Peter and David, what are your personal research interests? What have you been working on before the center started?
Well, I can start. Before the center started, I've been working in quantum information for at least 20, 25 years. Okay, so I have not started 3 months ago. So I started working while I was staff member at Los Alamos National Laboratory. So I've been working since then on different aspects of quantum information and also condensed matter physics. So my research essentially covers two different things which are related to quantum matter and things which are related to the aspects of quantum information that have something to do with quantum matter. Okay, for example, topological quantum matter. Okay, topological quantum matter is something of interest, for example, to Microsoft for building the topological quantum computer. Okay, that's one of the applications. Apart from the fact that topological materials may have some functionalities which are special, okay, for sensing and for other things. I work also on things that have to do with trying in quantum sensing, with trying to find ways to increase accuracy and precision in measurements, and also to extract additional information by entangling quantum probes. Like, for example, developing entangled neutrons. Okay. And well, I could continue, for a long time, but I think that I will leave this to Peter.
okay, sure. I've spent it seems like forever now in the world of essentially supercomputing, massive parallelism, alternative models of execution of program uh, computation, and I just finished a book on that subject. And so my interest, near term anyway, is understanding uh, what parameters of quantum computers are going to be in fact those that are most suitable for real problems, particularly big problems for which we need to spend we can afford to spend the money to switch to something that's quantum based. And Gerardo mentioned the benchmarking project, and that was one that I put together. And in fact, I was going to mention this. One of the neat things about these projects is they've made for excellent fodder for attracting grad students because they're well defined projects, and I can put that list up in front of some grad students, and those who have an interest in a particular area will come and see me. In fact, I have a new student from South Africa whose interest is in quantum and particularly quantum machine learning. He in fact won a scholarship, so he's going to be working on CQT projects regardless of whether or not they're funded. So anyway,
Yeah, and I can go. I'm actually a chemist by training. I spent several years working at the Air Force Research Lab on photonic materials. Um, have since transitioned into my role at Purdue, which is not as a researcher, but more in business development management, to really help our faculty find funding opportunities and to build partnerships with stakeholders from academia, industry, and government to help Purdue.
So
David,
let me add one
I
thing.
believe I'm guessing that the process of setting up the center was a huge effort. You know, I can imagine both herding the cats, so to speak, creating the proposal, going through the bureaucracy, and so on. Um, so if I'm in a different part of the country and I'm hearing this podcast and I say, wow, I'd like to do something like this as well. What do I need to know to build a similar center? And would you be willing to help me if I were trying to do that?
That's an interesting question. NSF funds a number of these centers, but they don't fund multiple IUCRCs on the same topic. So unless there's one significantly different than the focus of ours, we'll really be the only quantum one. Um, I'd be happy to give advice to people not in the quantum field on how to go about this. But the good thing about this is that we can expand if it makes sense for us. We can bring in other academic partners. A lot has to be needed for that. There, has to be some type of expertise that another university provides that we can't already with our, already 100+ faculty members. So we also have minimum membership levels that we have to maintain that increase as you add more partners. So while we're certainly open to exploring, and we'd love to hear from other people to see if that makes sense, it does have to be the right fit for that to happen.
And I'd like just to amplify a bit on that in terms of help to other similar kinds of centers. You absolutely have to have somebody like David, who is technically competent and works well with people from different sites. That is absolutely the number one requirement.
I was listening to the list of sponsors, and don't think I heard a cloud provider. What do you do about hardware or actually running quantum software? Do you want to have a quantum computer, within the universities? Are you expecting to partner with one of the large cloud providers? How does that work in terms of execution of programs?
So you're talking about development of quantum hardware?
Or execution of quantum algorithms on various types of hardware?
Okay. So these are separate questions. So execution, some of our members indeed have quantum computers. Okay. IBM, for example, quantum. Okay. And indeed part of the task we have is essentially trying to see for instance, how to use those quantum computers in an optimal way, okay, and in some way, help them. I mean, improve their hardware. Okay. Then there is also specific elements that are hardware elements which are developed. Okay. For example, at Purdue in the engineering school. Okay. Hardware that trying to build better qubits. So how can you build better qubits than the ones which are available in these industries? Okay, for instance. Okay, so that's what what concerns the hardware itself. Now, what concerns the use and the hardware. Now, of course, we would like to develop our own technologies, okay, our own expertise to develop other types. Okay, for example, we have groups here at IU that are working on on two-dimensional ion traps. Okay, so in principle, these two-dimensional ion traps are developed for quantum simulations, but eventually, these researchers are thinking about converting this into a quantum computer. Okay, so I mean, there are the two aspects, okay, to the story. I don't know if Peter wants to add something to that.
Yeah, I do. One our discussions, and this was one of the valuable things that came out of the pre-contract discussions with industry, was a fair number of the people we talked to felt long term it was important to understand how to build not just singular quantum computers and or quantum networks, but clouds, networks of quantum computers. And how do you design out, not just to use those for capacity, but how to use those collaboratively to solve problems. So this is an area of quantum computing that is liable to be of real interest. How do we build quantum algorithms that span multiple quantum physical computers?
We spoke about sponsors and grad students. Are there other types of people, different types of education that might be interested in participating? And what do the grad students do other than their actual research?
That's a great question. Indeed, graduate students and undergraduate students are key, okay, to the center. They are not only the blood, okay, of the research, but at the same time, they have the possibility to interact directly with industrial partners. And they have the possibility to learn exactly what are their interests and their problems through different channels. One of the channels is, for instance, through internships. Okay. So, and also presentations. They have to present and they have to update their research on a monthly or, bi-monthly way. And that's a kind of unique thing because they know what is the real world out there. Okay. And they try to influence that interaction. So this happens with undergrads and grads. But what is really interesting, or the reason why I said it's a very interesting question, because this goes beyond college students, okay, undergrads and grad students. This goes also to high school students, students that are hearing here and there, okay, about quantum, very smart ones, okay, that they want to learn and they want to do research. So I have two high school students right now working with me, okay, and I can tell you these guys are really bright, okay. One is 14 years old, okay, 14 years old, and he's learning about retrodictive quantum computing, okay, some new ideas. And it's unbelievable, okay, the way these guys learn and their excitement about these things. So yeah, I mean, it is extremely important to get all these bright guys that are at a very young age and get involved in this enterprise, because this is the future. Okay, this is the future, and this is where in 20 years we are going to be.
Excellent. So, if I'm a sponsor and a commercial organization that wants to get involved in the center, or if I'm a grad student that's looking for the best home for my research or my research interests, what's the best way to reach out and contact you to learn about your work?
Yeah, you can check out our website, which is purdue.edu/CQT, or you can email cqt@purdue.edu, and then we will certainly get in touch.
Perfect. Well, thank you so much for joining me today.
Thank you very much.
Thanks so much for having us.